Would Jordan Roderick and Ty Goldry report to the vice area, please? Jordan Roderick and Ty Goldry to the vice area, please.
In this podcast, we're going to just explore the concept of solving polynomial equations. I'm often asked about the type of factoring that we do in this course and why we go through that. And the reason is that we need those factoring skills in order to solve equations in applications like this one. So as we go through the video, if you find that you need time to get caught up, please feel free to pause, rewind, and continue playing as you need to. So in the first example, we have an open top box that's being constructed from a piece of cardboard by cutting congruent squares from the corners and folding up the sides. So try to imagine how these squares, which are congruent, that is, they are all of the same size, they all have the same area, they're going to be cut out, and then the sides are going to be folded up to create a box. Okay. The dimensions of the box are provided. You can see full width without squares removed as 24 and a full length of 36. So here's the question that I'd like to pose. What is the value of x that will give us a box with a specific volume, a specific capacity, specifically 748 centimeters cubed? So our first task is to express the volume of the box as a function. So we need an equation that gives us the volume of the box. Secondly, we're going to figure out what kind of restrictions should we put on the domain based on the conditions in the problem. Okay, so let's build that function. So why don't we let v at x represent the volume of the box? So let v at x be the volume of the box in cubic centimeters. Okay, and from that statement we can kind of deduce that x would be the length of a side, right? Or in this case, the length of a side of one of the squares. So with that in mind, we're going to need dimensions for length, width, and height. If we look to the diagram, by subtracting out the values of x, what we're going to see is that this portion here, if I were just to highlight that, we'd have a length of 24 minus 2x. And by the same token, if we were to examine this dimension of the box, upon folding it up, we'd have 36 minus 2x. So when you fold the box up, note that the height, right? The height of this box is going to be made up by this length here. So we can see that the height of our box is going to be equal to x. So therefore, using function notation, right, we would have v at x equal to the height x multiplied by the length and the width. So we have a length of 36 minus 2x. We also have a width of 24 minus 2x. Okay? So what we'll go ahead and do is we'll now tackle the next part of the problem. and that is, what are the restrictions that we need to consider for the dimensions, for the value of x? Okay, so I'm going to insert a slide here. I'm also going to bring forth our equation that we have here. So I'm just going to group this together. Actually, I'll copy it and I'll bring that forward here. Okay, so restrictions on the value of x. Well, I think it stands to reason that x must be positive. Okay, we're talking about a length, so its magnitude has to be positive. I think it also makes sense to say that any of the other dimensions, right? This would have to be positive, and this dimension needs to be larger than 0 or positive. So if we go ahead and we solve these small inequalities for x, we'd have 36 greater than 2x, which means that 18, right? Divide by 2 on both sides, 18 would be greater than x. Over here, we'd have 24 greater than 2x, which means that 12 would be bigger than x. So if you look at the statement we have now, the smallest conceivable values, right, would have to be bigger than 0, right? We can see that here. Not including it, of course, because that simply wouldn't make sense. And the largest value that you can see would have to be smaller than 18. Okay? And you can see that the 12 would be in between. So therefore, from what we can see above, right, we could therefore say that the restrictions on our domain would have to be such that 0 is smaller than x is smaller than 18. Note that we cannot put an equality symbol here because of the fact that 36 minus 2/18 would give you 0. And 0 is not permissible. Right? We can't have a dimension of the box that is 0. So therefore, 0 is less than x is less than 18. Just going to check our time. We're up to a running time of 8 minutes and 25 seconds. So we're going to try to do this in a 2-part series, about 2 15-minute videos. So now that we have the restrictions set in place, the function equation is set, we're now in a position to use that equation. Let's do that. Okay. So let's set the function equal to the given volume. So I'm going to bring that function equation into place here, and we're going to set it equal to the volume. So the volume given was 748. Now our task is to try to isolate the 748 to one side, and by doing so we'll produce a 0. And we'll multiply that by 24 minus 2x. So in isolating the 748, it gets subtracted from the right-hand side. All right, so let's have a look at what we have so far. you might notice something of convenience here. And that is this, that this factor, 36 minus 2x and 24 minus 2x, we can both see that 2 is a common factor. So why don't we do some common factoring? So if we were to pull out a 2 from that factor, we'd have 18 minus x. And if we pull a 2 from the next factor, we'd have 12 minus x. And let's leave the 748 there for now. So what we'll do is let's group these 2's together. And why don't we write another line underneath, and let's bring the 2's grouped together into that line. So let's write that as 2 by 2, which is 4. And then we'll write all the other factors that we have. So we have x, 18 minus x, and then 12 minus x. And of course we've got this constant term that happens to be on the end, which is 748. And all of that's equal to 0. And just to reiterate, the 0 that's there, we're trying to find an x value that makes the function equal to 0, which graphically are the zeros. So we're trying to find zeros. Now you might also notice something else, and that is the fact that as one whole term, we could divide 4 out as a common factor from this term. Okay, so I'm going to physically show it. We don't need to, but you might see that as being divisible by 4. And if we divide that term by 4, the hope is that we can cut that term down by 4 as well. And over here, we'll divide the left-hand side by 4. The result being 0 is equal to x on 2. 18 minus x on to 12 minus x. And that's as a result of the 4's canceling out here. Here on the end, though, on the other hand, when we divide by the 4, we need to determine 748 divided by 4. Okay? So let's see what that's going to do for us. So we can either do a little long division, we can use our calculator if we need to. Give our minds a bit of a break and determine 187 is the quotient there. So minus 187. Okay. So I'm just going to look into my notes currently to see what I had planned up for step 3, and forgetting to put that in. You might want to insert that in here before we move further ahead in the video. Okay, we can set that into place so that you have that note written in for later on. And we're actually almost at the point where we're ready to solve this equation. We just have a little more work to do. Let's check our running time. We're at 14 minutes, so we're almost good to go with closing off this first part. So the last thing we need to do is to expand, gather like terms, and then we'll have a look at step 4 in the next video. So we have 0 being equal to. Let's deal with expanding the x into the first bracket. So we'll come up with 18x minus x squared. Okay, that's a result of the first expansion. Then what we'll do is we're going to multiply that over the 12 minus x. So we should expect to see 4 products coming out from expanding those two binomials. So we need to multiply 12 by 180. Okay, I believe the response there is 216, although we'll double check so as not to make any errors in recording. So good, 216. Mental math is working correctly. So we have 216x, okay, as a result of multiplying 18x by 12. Well, let's follow through with 18x times negative x, and we'll have negative 18x squared. As we continue with the negative x squared term, we'll have minus 12x squared, followed by positive x cubed minus 187. Gathering our like terms and putting the terms in descending order of degree will bring the x cubed out first. We'll then combine our squared terms together, so these two, for a total of negative 30x squared plus the 216 minus 187. Okay, so in the next video what we're going to do is we are then going to solve the equation. That is to determine the roots to the equation using a factoring strategy, otherwise known as, right, aka factor theorem.